Hello everyone, my name is Walter and this will be my presentation for the banker's algorithm simulation. So let's start off by looking at the main data structures that control the simulation. It's going to be right here, the global arrays that were provided to us for this assignment. So for these arrays available, it's going to hold how many units of each resource type are currently free. Maximums will come from the max text, and this is going to list the maximum demand for each process. Here in allocation, it's going to show how many resources each customer currently holds. And then here in the need array, it's going to show how much more each process still needs. And this will be calculated by our calculate need function, which is going to be this one right here, so you guys can see it. Just find it. It'll be right here, and this will be need arrays is equal to maximum math allocation. And then these four arrays are going to update whenever a request or release occurs, and it's going to keep track of the entire system state. So then here in main, I'm going to show the commands that will be handled. And here in main, the request will be handled right here. And then the release is going to be handled right here. And then for this, when a user enters the arg command, is going to call the request resource function. So when it calls the function, it will call this function right here. Where it calls this function, it's going to check that it doesn't exceed the customer's need. It's going to check that the resources are available. It's going to temporarily allocate to verify the state. And then if the system is safe, it's going to approve / grant the request. And if not, it's going to be rolled back. And this will be the function right here. So for the release command, it's basically going to be the same. It's going to call the release resource function, and then the release resource function. It's going to be this one right here. So then here we're going to have the safety algorithm. And then it's going to start by copying a copy of the real array into a temporary array, which we're going to call work. Then it's going to loop through every process. If the process needs can be satisfied by work, we pretend it finishes. If we can't find the allocations, it's safe or unsafe, and it prevents the system from entering the state that could cause a deadlock. For the debugging process, the only thing I would have was it's right here. Originally, when I was running it, I was getting this warning, and then it was still letting me compile. But when it would compile, I was having double prints of request denied. After looking through the code, I realized that I had the request denied both in the main, where if it wasn't equal to 0, it would print request denied. And then I also had it and the safety algorithm. I have it right here. So basically here, it will print out double. So once I went ahead and deleted the print statements here and recompiled, the warning and the double print were satisfied. So as you can see, I removed it. When I went, we got only one print and there was no warning. So now let's go to the live demo. So if you go to a live demo, you can see already compiled it with the GCC. So we're just gonna go ahead and run just the banker dash banker. We'll go run right here so we can show everything works as it should. Banker 10, 7, 8. So far so good. So now we're gonna enter a safe request. And it's gonna be RQ 03121, and then it's gonna say request granted, system is a safe state, right? So then we're gonna go ahead and try an unsafe state. We're gonna go RQ. We're gonna go RQ 21111. And then right here, the program denies it because the safety check failed. And then we're gonna go and release 03121. So then you can see the program successfully releases it. And then when we go ahead and hit the command, we're gonna see that everything was released. So we still have this available. Everything went back to how it was. And then the request. Let's see, so let's go ahead and just double check the checklist. We ran it, like demo, cuts, challenges, everything's good. So then for the walkthrough, for RQ 21111, this was denied because the request was unsafe. When process 2 asked for extra resources, the algorithm couldn't find any order where all the processes could complete. So I wrote back to the change, proving that the system is in a safe state. This approach ensured mutual exclusion, process, and bound waiting. No one waits forever. Once it's safe, the request is granted. For progress, it keeps running when it's safe. And then for exclusion, only one process holds a resource at a time. So we're going ahead, we did everything, deny request, double check this checklist, and yeah, everyone, this is my code. Thank you very much.